Excuse me. Okay, so the bad news about concentration of solutions is concentration is a ratio, isn't it? So you have to be careful about that word. The other bad news is over the time, there's been lots of ways that people want to represent concentration. Every one of these is a concentration unit. Now, the only time I want to use this was that solubility graph. You get that? And since I already gave you a grade on that, I probably will only have like 6 questions on the main test. The main test will probably only have maybe 6 questions on that. So don't expect like huge numbers of questions on the solubility graph. We did a little bit with percent by mass and percent by volume, but you actually knew how to do that without me teaching it. I'm not worried about that. But I want to spend all my time now on this one here called molarity. Okay, so molarity is the star of the show, without a doubt. So we're going to get into molarity. Now, this is a weird handout sheet because when I was reviewing one year, I just had an index card, and they said, do we have to memorize the equation? I said, well, how many are there in this chapter? There are not very many. And so I listed these, and I put on an index card. I said, can I have a copy of that? Can I have a copy of that? So I just went ahead and photocopied it, my index card, and that's why it looks the way it does. But so if you said, I need to know the equations, well, percent by mass or percent by volume is, you always divide by the total. We've done that before. So I'm going to check that off because I think you're pretty good at that. Now, molarity, we're going to do some molarity problems today. And then look at this equation here. Ooh, that's a different equation, isn't it? Is it? It's not. But I'll tell you what, I wrote it down separately because you're going to find that you'll probably use this equation more than any other equation, even though it's the same one as this. It's the same one as that. I just rearranged it. You get it? And here's what's going to happen. For the next 2 days, every time you read a story problem, it says something like it has a molarity and a volume. A little bell goes off in your head. You say, ding, 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 ding. Molarity times volume equals what? Moles. And now all of a sudden it's like last chapter. I'm in the mole world. What do you want me to do? I'm in the mole world. Now I can do whatever you want. And this is like last chapter. It is like last chapter, except you have to get into the mole world. And how we do it? Molarity times volume equals moles. All right, so let's go ahead and let's show, let's look at number 1. Calculate the molarity when 75 grams, blah, 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 blah. Okay, ready? So when they said calculate the molarity, what's your equation going to be? Molarity equals, what's the definition? Man. Hey, I can't, I know it, but do you know it? Does everybody in here know the definition of molarity? It's the star. What is it again? Help me out. Let me call on John. John knows. What's the definition for molarity? Yes, moles of solute. Over what now? Of what? Of what? There you go. Now, everybody got that? So that's it. That's the star. This is the star of the show. So they want me to find molarity. They better give me, what if they give me moles and liters? Well, just put in the calculator and divide. What if they give me grams and liters? What are you going to do? I'm going to use a shortcut. Change grams to what? And then divide. What if they give me moles and milliliters? Yes?
I did not get that sheet.
This one right here?
Yes.
Oh, okay. Did you put the extras back there? Here, go back there. Go back there and get one. Maybe you were passing out papers. That's what happened. That's what it was. What? Okay. All right.
I don't know about that.
Okay, so anyway, we talked about this before. You're not going to trick me. If you give me moles and liters, I know what to do. You give me grams, liters, I'm going to change grams to moles. You give me milliliters, I'm going to change milliliters to liters, and you're not going to trick me. I don't want you to look at me and say, I don't know how to do that problem because they give me milliliters. No, you're big boys and girls, okay? You're certified in many areas, aren't you? Now, let's try number one. What are they going to give me? They're giving me grams of solute, and then what? Oh, they're starting off with a tricky one, aren't they? All right, shortcut. Are you ready for shortcut? Shortcut, when you're in grams, right? How do you go down in the mole world? Divide by the molar mass. Let's do it. What's the molar mass? What's the molar mass of MgCl2? I'll tell you right now, 2 chlorines. Everybody should have this down now. What's 2 chlorines? 71, isn't it? 71. And what's magnesium? How much? 24.3. Okay, so I can do that in my head. 95.3. Is that right? Okay, let's do it. Change this into moles. Divide by 95.3. What do you have? Ethan, you have it? You have a calculator?
Yes.
Yeah, you need a calculator. Max, what do you have?
0.7.
What's your next number?
Oh wait, no, 7, 8.
787? Is everybody getting that? All right, that's moles, right? And then, what about this? How do you change milliliters into liters? Divide by 1,000. All right? You can do factor label, or just a fast way of doing it is 500 milliliters is half of a liter, isn't it? So I'm going to say 0.5 liters of solution. And then, look at this. This is easy. All right. Final answer, Caroline. 0.787 divided by 0.5. Okay, and what's your units? Ooh, watch this now. What's the units? The top unit is called moles of solute, and the bottom unit is liters. So what's your, what is this? Moles per liter. But what does moles per liter of solution mean? What does moles of solute per liters of solution mean? Molarity. So what's my, my final thing is big M, isn't it? Are you with me? All right. Do the second one by yourself or with a partner. Do it by yourself or with a partner. They're being tricky here. They're giving me the volume of the solution, and they're giving me the molarity, and they want me to find, oh, what am I going to do here? Now remember I put a star on this? It's the same equation rearranged. But when I see you give me molarity, and I see you give me volume, ding, 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 ding. Molarity times volume gives you what? Moles. But they didn't ask for moles. Yeah, but if you get moles, do you know how to change moles into grams? Look at my hands here. How do you go from moles up into the gram world? And multiply by molar mass. See that? The only reason I was a little nervous about you on the test on Friday, I don't think you've practiced this enough to be fast. You have to have a certain amount of speed on these. You get it? So I want you to start picking up the speed a little bit in the next 3 days. What is this, potassium carbonate? Ooh, that's a tricky one. Oh, you know what? What's carbonate's charge? What's carbonate's charge? What's the charge on carbonate? -2. What is potassium's? Oh, man, it got me on that one. All right, so do the molar mass. All right, somebody else, Ty. What do you have? What's 2.5 times 0.2?
0.5.
Okay. And do you know what kind of units that's in that? What is that?
Moles.
That's right. Do you know how that works? So it's big M is moles per liter. What's moles per liter times liters? What's moles per liter times liters? What's moles per liter times liters? That's moles, isn't it? So that's what you got, mole. That's moles. Now, what's the fast way to change that to grams? All right, and the molar, what do you know the molar mass this is?
I got 138.2.
138 point what? Is everybody getting that? Is everybody getting about 138? Okay, so let's do it. You did a great job so far. Go ahead and finish your problem out for us.
I got 69.1.
Is everybody getting that?
60.
60. What is it? 69?
60.
What?
69. 69.
60.
9.
I thought I wrote 69. 69?
Oh,
No.
I thought you put 59.
What? Oh, did I say 59? My fault. 69. Point. Is everybody getting 69.1? Yes or no? Okay. Now, are you feeling a little bit better? You said, "What? I think I can do these problems." Right? They tried to trick me. They tried to say grams. I didn't know what I was doing, but I knew if I got in the mole world, I knew how to go from moles to grams. I even know how to go grams to moles, don't I? That should give you some confidence. All right, let's do the next one. I think I see molarity times volume. I think I see molarity times volume here. Ding, 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 ding. Did you get molar mass at 101.5? Okay. I want to make sure I do it in my head, so. Okay. Let me, how about, see who's almost done here. Oh, Wooden, you're done. All right, help me out. Did you see molarity and volume in here? A little bell go off in your head, and you said molarity times volume gives you what? All right, did you do that or not?
Yeah.
Okay, what'd you get for the number of moles?
You gave 8.4 moles.
But they didn't want to know how many moles. They want to know what? So what'd you do then?
Then I multiplied it by 101.5.
Excellent. Man, you're sounding good. So what's your final answer?
816.1.
16.1?
Yeah. Yep.
Is everybody getting something like that? Wow. We can do these molarity problems, can't we? Everybody okay? The more of these we do, the more confident you're going to be, isn't it? All right. Let's do one more, and then I need to teach you a little bit after that. So let's everybody do number 4, and then when you get finished, compare it to somebody sitting next to you, and see if you get the same answer. All right? Find the molarity. Adam, have you been enjoying these last 3 chapters? I just wondered, if I were you, and let's say every day the chemistry said, well, how many phenes are there today? How many phenes did you get? What do you multiply? Does that ever happen to you? You say, I'm feeling pretty good about it. No? I mean, all right. All right, when you get finished, compare it to somebody, and if they don't get the same answer, then you start teaching them and say, wait, did you change this to this? Did you do this? Did you do that? All right, find somebody that you can see. If, I don't know the answer. I don't have the answer in front of me, but wow, that's not very many moles, is it? Man, that's tiny, isn't it? 0.5 grams. Wow, that's a tiny number of moles, isn't it? But look at the volume. Look at the volume. That's tiny too, isn't it? Wow. I don't know what this is going to come out to be. All right. How many people you got the same answer as the partner you looked at? All right. Who did not match? Whose partners did not match? Okay. So I don't know what the answer is. Do you know what the answer is, Kayla? Oh, did you match somebody? No. Oh, okay. All right. Noah Ramos, did you match somebody?
Yeah.
What'd you get for an answer?
0.171.
But what's the unit?
Big M.
That's right. Now, can I tell you a bad mistake? Don't make this mistake. Big M does not mean moles. You got it? What is big M? Moles of solute per what? Liter of solution, right? Big M is not moles. So make sure you understand that. All right. Now, I haven't done this problem, but here's what I think I would have done. And let's say I had a test like you guys have, and I want to pick up my speed a little bit. I'd say I need moles and I need liters, okay? They give me grams. You're not going to trick me. What's the fastest way to change grams to mole? Divide by the molar mass, okay? Does everybody do that? Now, 0.5 divided by 58.5, that's going to give you a tiny number, isn't it? It's going to be pretty small. And then, so I put that up here. And then what about liters? Whoa, that's a tiny number too. So I divide by 0.05 liters. And raise your hand if you got something like that. You might have rounded off a little differently, but all right, that must be the answer then. So what do you think?
Good.
Are you feeling more confident about that?
Yes, sir.
And I think I could finish the chapter tomorrow, but I think I'd be rushing a little bit. So what I don't want to do is I don't want to go too fast and then you not be successful. I want you to be successful if you work hard. I want to show you now. We've just taken the molarity equation and rearranged it, and we use that. We use that a lot. I will tell you, you use those. It's the same equation. I just rearranged it. But now we're going to go to the next one. Now this one is called the, down here, I'm sorry, down here. Oh, I know. I need to teach you a lesson here. Let me ask you a question here. What is the molarity of this solution? What is the molarity of this solution? What is the concentration of this solution right here? So what is the concentration of this solution? What's the concentration of NaCl? What would you put as your answer? The one we just did. What is the concentration of this solution? Does everybody know what they would put? See, right now you can do the math, but you're having a little trouble with this because it has to do with your vocabulary. What is the concentration of this NaCl solution? Davis. Yes, because molarity is a concentration unit, isn't it? So it's 0.171 molar. It is called molarity, but it's a 0.171 molar solution. Get it? Now, I want to teach you something else here. I want to know what is the concentration of sodium ions. What is the concentration of sodium ions? Now, this is not math. This is conceptual thinking. You get it? All right. Jonathan, what is the concentration of sodium ions? You are correct. What kind of units? Okay, big M. Now, how did I know that? Because this said you had 0.171 moles of NaCl for every liter of solution. And that big M means moles per liter, right? So if you had 0.171 moles of NaCl for every liter, then how many moles of Na were in there? So imagine this is an NaCl. You get that? And I say you had 0.171 moles of that in a liter. Well, then how many NAs would be in there? And you say to yourself, wait a minute. For every one of those, how many NAs are there? If you tell me I had 100 of these in there, NaCls, then how many NAs would be in there? I gotta have some quick answers here. One more time. If I said you had 100 NaCl somewhere, and I said how many NAs would there be in there? 100, wouldn't there? For every one of those, how many NAs do you get? For every one NaCl, how many NAs do you get? 1. So the concentration of NaCl will be the same as the concentration of Na, wouldn't it? Try another one. What's the concentration of Cl ions? What's the concentration of chloride ions? All right, Ethan, you do that one. What's the concentration of chloride ions, Ethan?
Not sure.
Okay, so part of the test is mathematics. I get it. But part of it is thinking conceptually. Get it? Ethan, if I give you 100 NaCls, okay, 100 NaCls, all right, how many NAs would be in there? How many Cls would be in there?
100.
Okay, so the concentration, what if I told you you have 100 NaCls, you'd have 100 NAs, and you'd have what?
Hundreds.
100 Cl. So if the concentration of NaCl is 0.171, what's the concentration of sodium ions? And Jonathan said 0.171 moles per liter. What's the concentration of chloride ions?
0.7.
0.17. Okay, everybody get that? Now Tyler's back there waiting and says, come on, this is easy, boys. So I have the tough question for you, Tyler. I didn't hear you say that, but okay. So now I have one for you, Tyler. What's the concentration of any kind of ion in this solution? I'll give you a clue. For every one of these, how many ions do you get? Ah. He's going to do it. I can tell. Wait, 0.3 what? 2? Yeah, 0.342? That was good. That's good. See that? One more little mini lesson, okay? All right. Who thinks I got this whole thing? I got this whole thing. You cannot fool me. I'm gonna ask you 4 questions in a row, and all you have to do is get all 4 questions right. Who's ready? Come on, somebody do it. Take a chance, all right? Nobody else is raising their hand. All right, Caroline, ready? What is the concentration? I made a 3 molar solution of barium chloride. What is the concentration of barium chloride? What is the concentration of barium chloride? How much? Ding, 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 ding. You're almost there. 3 more. What is the concentration of barium ions in this solution? Ding, 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 ding. What's the concentration of chloride ions in this solution? How much? What is the concentration of chloride ions in this solution? Ding, 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 ding. For every one of these, you get how many chloride ions? Okay, final question. What is the concentration of ions, any kind of ions, in this solution? Ding, 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 ding. Wow, that was good.
Way to go, Caroline.
That was good. Okay, everybody okay on that? That was a little small lesson. I know I want to start another small lesson here. But I wanted to show that to you because I noticed that in my little index card, I said to get ready for the test, make sure you know how to do the molarity and both ways, and then be able to conceptualize concentration with ions or things like that. Okay. And then we'll go down here this next one. I'll show you a picture here. Now, excuse me. I've done this many times here at this school. And it's where I'm getting ready to do a lab, and the lab instructions tell me, well, if you want your kids to do this lab, you need a 3 molar, blah, 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 whatever it is, okay? And I could buy it. I could have the school say, spend these people's money to buy that stuff already made. And I might be able to, it might cost about $30 to get a couple bottles of the stuff already made. But I don't want to do that. And I guess I'm semi-smart, and what I would do is I could buy the chemical, a big bottle of chemical, and for the next 10 years, I could make solutions myself, can't I? If I know how to make solutions, then I can just take the chemical, and I'll just make them every year. I'll go get some distilled water, and I'll make it. So the picture you're going to see right here is if I know how many moles I put in there, and I know the total volume, won't I know the molarity of that solution? Won't I know it because I made it? Well, guess what? What's the fancy way of calling that solution? What's a fancy name for that solution? And I have vocabulary words on the test, so what do you think? What would you call that? In science, they call that a known. You know why? Because I know the concentration. Another word they would use besides known is standard. It's a standard solution. What does that mean? Standard solution. What does it mean? You know it. You know what the concentration is because you made it. Now I can buy it. It's still called a known because they had their chemist make it, right? They say, why are you even telling me about this? Because we're going to use this idea later. I want you to show you something else here in there. I'm going to go to page 462. I want you to pretend now I've already made a solution. And I said, I know sometime during this year I'm going to make it. But then I find out that the lab calls for something that's not as concentrated. All right, one more time. I could ask the school to spend your money, call the company, all right, I'm going to have to pay for shipping and everything. And they'll have somebody there make something, instead of being 2 molar, they'll make it 0.5 molar. And I could buy it, can't I? Or what can I do? What if I already have a bottle, a standard solution that I know that, and couldn't I dilute it? If I knew what I was doing, couldn't I simply dilute the 2 molar down to 0.5 molar? And so that's what I want to show you how it is. This is pretty easy. I think you're going to like it. And so here's what we're doing. We're going to take the stock solution, also known as a standard standard solution, stock solution, known solution. Okay, I don't care what you want to call it. There you go. All right. I happen to know that I can order an acid and I can get it cheap if I order a big bottle of this. And do you know what 13 molar is? Do you think that might hurt me? Any ideas? Do you know that most of the time in first year chemistry, the things you use are 0.1 molar? Most of the chemicals I have for you is 0.1 molar. What do you think about 13 molar? That's pretty concentrated. I can order an acid that's really, really concentrated, but I'd rather you not touch it, don't I? I don't want to do an experiment where you use 13 molar, do I? So maybe I do an experiment with you that I want to change it to 1 molar or 2 molar, and you'll less likely to be hurt. How do we do that? How do we do that? And this is kind of neat. This is very neat how this works. M1V1 equals M2V2. What do you mean? What are you talking about? What's this stand for here? This stands for the molarity of the stuff you start with. Oh, okay. What's this stand for? The volume of that material you're going to come out and take out. Oh, okay. Well, what's this? What's M2? Remember, my goal is to take something that's dangerous and turn it into something not so dangerous, isn't that right? What do you think M2 is? Who have not called on today? Madeline, what do you think M2 is? This is the molarity of the stock solution that I start with. What do you think M2 is going to be? Okay, I think you lost track of my goal. What's my goal? I have this really dangerous, very concentrated acid. I don't want you to touch it. I'm going to do an experiment where you're not going to have 13 molar, but what are you going to have? Maybe 0.1 molar, maybe 1 molar. Okay, so one more time. This is the molarity of the first stuff. This is the volume of that I'm going to take out. And this is going to be the molarity of the, say it. Okay, you don't have the picture. Okay, that's fine. Who has a picture? Who thinks they have a picture of what I'm doing? Uh-oh. I haven't called in Danielle. What's M2 stand for? Yes, the second molarity, the one that's not going to hurt you, right? And what do you think the volume of the second? What do you think V2 stands for? Of the second one, right? You know, this is neat. This is neat, and so we can do this. I'll show you. Where's my paper at? Oh, it's down here. All right, let's do one. Now watch right here. Oh, look, it's called a what? A dilution problem. Let's do a dilution problem. And right away, I want you to write this down. M1 times V1 equals M2 times V2. Okay. Now I'll give you a little clue. Your math teachers probably said this many times that you didn't understand what they meant. You can't solve you can only solve for one unknown. Have you ever heard a math teacher say that? So watch, I have a problem here, don't I? It looks like there's 4 unknowns. No, we can't do that. If I want you to solve this problem, I better give you 3 of the 4 things, don't I? Otherwise, you can't solve for 2 unknowns. So let's try it. What volume of concentrated sulfuric acid, 18 molar, that really hurt me, is required to prepare, this is what I really want to do, 5 liters of what? That won't hurt them. 0.15 molar by diluting. Okay. Who have I not called on? Elizabeth. Elizabeth, what is the first molarity? What's the molarity of the stuff I'm going to start with? 18. Excellent. 18 big M, right? All right. What is the volume of that concentrated acid? How much am I going to take out of that bottle? All right, I'm gonna skip that for a minute because when I get done, what am I want? Elizabeth, when I get done, what do I want? That's the second molarity, right? And how much volume when I get done? There we go. So this one, they never did, that's my X, isn't it? In algebra, they call that X. Now, I know that you guys are good in math, or else I don't think you'd even be in here. But I'm not your math teacher, but how would I put this in a calculator? Does everybody know how to do it in a calculator? You know it's this times this divided by that? This times this divided by that? Isn't it? Isn't it? This times this, divide both sides by 18, all right? Let's try it. Anybody have it already? All right, anybody have it? You do? All right, what is it, Kayla?
Might not be right. They're not .042.
Point what?
042.
14?
4, 2. There's no 1 though.
Oh, there's no, oh, it's just point,
Yeah.
okay, I got you. So it's .042. Now, watch now, don't guess. What units? Okay, now, I'll show you a little guess. Watch this now. See a big M?
Yeah.
See a big M? Cancel. What's the only unit left? That's what it is. See that? Now, everybody with me? I happen to know, what if I had to make, I want you to pretend that that's what I'm supposed to do right now. I'm supposed to go make that right now. I want you to tell me, what would I have to do? And here's what I would do. I would go get, how do I measure that out? How do I measure? This is powerful stuff. I got to be careful of that anyway. But how much do I get? How do I measure out .042 liters? Anybody know? What is .042 liters? How big is that? So I'm gonna change this to milliliters. How many milliliters would this be? What is it? Oh, did you get 40? Did you get .042 here?
Yeah.
Okay, so if I move the decimal over 3 places, what I would do is I would go get 42 milliliters of this really dangerous stuff, 18 molar high sulfuric acid. Okay, now see that? So I go get that because you told me X. You said the volume that you're going to take out was this many liters, right? So I go get that, and I put it into a special container. Okay, all right. Hello. Okay. Oh, good. Upstairs, though? Okay, okay. Thanks. All right, bye. Thanks. You know the middle stairway you're not allowed to go to? Somebody's coming out that door. You know them. It's your mom. But anyway, so you're supposed to meet her there. Hey, wait, give me 15 seconds. 15 seconds. Wait a minute. 15 seconds.